Welcome back, guys, to Unit 7, our video notes. And what we're going to dive into today is an algebraic way to find our zeros. Previously, we've looked at zeros on graphs, and we've looked at zeros on tables. But how do we find the zeros if we don't have a graph, and we don't have a table, and all we have is an equation? What if we just have the equation of a quadratic function? How do we go about finding our zeros? All right. Well, one way to do that is to use a tag team approach. Right. Factoring is a process we should already know pretty well, hopefully. Right. If we need to go back to Unit 6, especially Unit 6, Target 2C, right, where we were factoring quadratics. That specifically is going to be really important. But what we're going to introduce here is a tag team partner for factoring, because factoring alone can't find zeros. But if we combine factoring with the zero product property, well, then we've really got a pretty powerful combination to algebraically find zeros from an equation. And these are the Road Warriors here. They were a famous tag team, WWF tag team, way back in the day in the 80s and 90s, right? But factoring, what we learned in Unit 6, will start the problem. Now, I will tell you guys, sometimes a quadratic might already be factored, and you don't even need this guy. But what we will always need is we will need zero product property. And this is what we're going to learn right now in this video. We're going to talk about zero product property. We're going to kind of look at how that works together a little bit. And in the next video, second video, we'll actually really get down to the nuts and bolts of actually finding the zeros in our quadratic functions. So let's talk about the zero product property. Now, this property is actually a very, very simple property. It's almost sometimes hard to understand because it is so simple. All right. So what this says, if a fully factored expression, so that is important, right? Zero product property only applies if you're dealing with a fully factored expression and it's equal to zero. So you got to have both of these prerequisite conditions for the zero product property to work. Then what we can conclude is that at least one of the factors is equal to zero, possibly more than one, but at least one. Essentially, what this is saying is it's impossible to multiply factors and get zero if one of them isn't zero. Think about it right now. Try and think of two numbers that you can multiply, get zero, but not have one of those numbers be zero. And as you think about this, you're going to quickly realize that's impossible. It's impossible to multiply two non-zero numbers and get zero. It's just not possible. That's what the zero product property is saying. The property itself is simple. It's the application of the property that we really care about. So if we have a situation like this is an equation where we have two factors. My first factor is x, and my second factor is x minus 3. Notice this is a fully factored expression, and it is equal to zero, what we need for the zero product property. Well, what can we conclude? Start that over. What can we conclude now about these factors? Well, either this first factor is equal to zero, or this second factor is equal to zero. Now, they can't be equal to zero at the same time because they're different factors. But we create essentially parallel, world lines, kind of like in the Avengers, where in one world line, this expression is equal to zero because x is equal to zero. And in a different parallel world line, this expression is equal to zero because x minus 3 is equal to 0. All right. And since both give us a possibility to make the equation true, both would give us solutions to the equation. All right. Now I kind of did a lot of math talk there. So let's actually look at it in action here. So if we want to solve this equation, remember, all solving we're doing, going way back to our very first set of notes, is we are trying to find values which make the equation True, right? That's all we're trying to do when we're solving way back in the day. So here's the question. What values of x could I substitute on in the left-hand side here that would make this equation true? In other words, what would make the left side of this equal sign equal to 0 so that it's true with what is on the right-hand side? Now, we don't have a way to do this other than using the zero product property, because what we see is I have one factor here in x, and I have a second factor in 2x plus 5. So in one world line, this is the factor that is equal to 0 and makes the equation true. So in one world line, I have x equals 0. But in another world line, right, the one where Thor went back and stole his hammer from the other world lines, Thor, you ever think about that? Like when Thor goes back and gets his hammer, like what does the Thor that's in that world do now? He doesn't have a hammer anymore. But regardless, let's get back to the math here, right? So what we see is we have two different ways that this equation can be true. This equation can be true if the first factor is equal to 0. This equation can be true if the second factor is equal to 0. Now, the nice thing about the first factor is, guys, you're done. X is isolated and it's equal to 0. The second factor, we got to do a little bit of work, but again, the nice thing is now this is no longer a quadratic equation. This is a linear equation. We're now way back to unit 2, where our strategy, once we get to here, guys, all we have to do, oops, that's not how you spell isolate, isolate the variable, right? So subtract 5, you get 2x equals negative 5. And we'll get x equals negative 5 halves. And so that would be our two solutions. So this equation is true in two different situations. The first situation is when x is equal to 0, this equation is true. When x equals negative 5 halves, this equation is true, making both of them solutions. Right? This can happen with either two equation. So I'm going to leave 2 alone here with two factors, right? I'm going to leave problem 2 alone, let you work on that and check your instant notes. But guys, this can work with any number of factors. As long as the expression is fully factored, written all as factors equal to 0, we can use the zero product property. So in this equation, guys, there's actually 3 different solutions. There are 3 different values of x which will make this equation true, which will make the left-hand side the same as the right-hand side. So we have a world line where negative 3x is equal to 0, and the equation is true. We have a world line where negative 4x plus 5 is equal to 0, and the equation is true. And we have a world line where x minus 7 is equal to 0, and the equation is true. Now, in all of these, we have to do just a little bit of work to solve for x. Here, we divide by negative 3 on both sides, and I get x equals 0. Here, I subtract 5. So I get negative 4x equals negative 5, and then divide by 4. So I get x equals 4/5. And then over here, I just need to add 7 to both sides. So what we have are 3 different values of x, but each one of them, when you plug it back into this expression, will make the equation true. 0 will be on the left, and 0 will end up being on the right, meaning we have 3 solutions. All right, so again, do 2 on your own. Check your work just to make sure we understand how to solve an equation with the zero product property. This fills in the second half of this, guys. This is all the zero product property is. We're essentially taking each factor that has a variable, and it's equal to 0, and we're splitting them off each into their own equation equal to 0 to find the solutions for the equation that we started with. All right, so how do we use this? What if, though, our equation is not equal to 0? Right? Well, that's where factoring comes in. The nice thing about these 3 problems here, sorry to jump around a little bit, the nice thing about all 3 of these problems, guys, is the expression on the left-hand side here was already factored for us. Notice, factored, factored, factored. Up here in this first example, not factored. So this is where we need the tag team partner of factoring. So we're going to have to take this quadratic in general form, x squared plus 13x plus 42, factor it, and then use the zero product property. Oh, but wait, I don't see a 0 anywhere in this equation. All right, so let me show you something, guys, you're going to see me do in every single problem in the notes, on the worksheets, and the study guides, and the formatives, right? And it comes from understanding our definition of the word zero. If we are trying to find the zeros, guys, what we are essentially saying, if we're looking for zeros, we are saying the range f of x, y is 0. So we can automatically know this relationship and substitute for f of x before we do any work in any of these problems to find the zeros. Technically, you can't find the zeros until you have replaced f of x with 0. So we'll get x squared plus 13x plus 42. All right, so we've done that. We've now replaced f of x with 0. So what I now have is 0 on one side, but this is not factored. So I'm going to do the factoring in green, and we'll do the zero product property in blue. So one thing we should notice here, guys, is that our leading coefficient is 1. So that means we automatically can use our shortcut to factoring this quadratic. So I need two numbers that will multiply to 42 and add to 13. I'll give you a second to think about that. Think. Yep, hopefully you got it. It is 6 and 7. So we take this as positive 6 and positive 7. And what we have now done in factoring is we have an equation where zero product property can be used. All right, so let's come over here. Now that factoring has done its job in the ring, let's pick up with zero product property. So we have this equation, x plus 6 and x plus 7 equal to 0. Well, in one world line, in one situation, x plus 6 is equal to 0 and makes this equation true. In another world line, x plus 7 is equal to 0 and makes this equation true. So this gives me x equals negative 6 and x equals negative 7 as the solutions to this equation, which means the zeros here are negative 6 and negative 7. Right? Those are the zeros of my original function that I started with. And that's it, guys. Factoring and then zero product property. They work together as a great tag team. So let's just summarize everything we've done here. So the first thing we always have to remember is that if we're finding zeros, we need to substitute 0 for f of x. Now, there may be times, guys, we give you a problem where we've already done that for you, but if we haven't, that's got to be the first thing you do. Then the next thing we do is we need to write the fully factored form. If it's not already factored, right? It may already be factored, but if it's not factored, we need to either use the AC method and grouping, right? That was kind of the long way, or our shortcut that we learned back in, this comes from Unit 6, Target 2C. So if you need a refresher on that, the test was last week, so hopefully it is fresh, but that's where we got that. And then, guys, we're going to use the zero product property to create the equations. And in each of those equations, in each of those different world line equations that we get from each factor, all we need to do is isolate the variable to get the zeros. Right? And that's what we're going to be working on. In our next video, guys, we're just going to hammer the nuts and bolts and work through a number of problems here to show you what we're doing. Hopefully that makes sense. If you have questions, please email me, send me them in ClassKick, and I would love to help. All right, I'll see you in the second video.